Well, we are live. It's 10 o'clock. I'm just going to wait a bit, give everybody a chance to get on before we get going. I've got the notes from yesterday still up on the screen. So if you didn't get a chance to look at that or you need to browse through any of that, it'll be up there at the moment for you to take a look at. I may have gotten it where I can actually see the YouTube chat again. So if that is something you prefer typing in instead of remind, that may work for us. I do not know. Both are still very functional things, though. Let's see. Give it about 4 more minutes, and we'll go ahead and get started. Didn't mean to hit that. Give about another minute. Well, we're at I'm showing 11 people watching at the moment, and I want to be respectful of your time. So let's go ahead and get going. If you take a look, I've already got up here what the notes were from yesterday, the last time. We've got fundamental Theorem of Algebra, how it tells us exactly how many roots there are, and that's all the types of number. That can be your rational ones or your non-rational ones. Non-rational being the irrational and imaginary. And let's see, we worked through a couple of problems. And then we talked about the super cool, wonderful world of multiplicity, which basically tells us that a single number can occur more than once. Okay? And we did one example with that. Right here, we had the number 3 that showed up as a root or a 0 twice, meaning its multiplicity was 2. All right, so that's where we left off yesterday. Today, and I got a lot of questions about this from folks when they were working on the Schoology assignments last night. How do we deal with the non-rational roots? Now, for you guys, I'm going to essentially assure you you're not going to have any more than 2. And if you have any, it will not be less than 2 either. It'll be exactly 2. Okay, so you could have 2 non-rational roots total. You could have 1 rational, 2 non-rational. You could have 2 and 2. You could have 3 and 2, 4 and 2, however you want to go. But you're always going to have 2 non-rational or no non-rational. There are other instances outside of that, but that's all we're going to do in here. All right, quadratic formula, guys. Not my absolute favorite way to go about these compared to completing the square, but based on what we've got, this kind of ends up being the best route to go, especially if in the case of this one, we have this number here, which is not 1, so it's non-monic, so there's that extra step. And then even more so, you've got an odd number there, so you're also looking at introducing some unnecessary fractions along the way. So just a quick recap on the quadratic formula, b squared minus 4ac. That's what you're going to start with. Alrighty, that's negative 5 squared minus 4 times a times c. Alrighty, and then you'll go ahead and, well, just type that into your calculator, or if you want to do it by hand, that's your call. Let's see, that's going to be 25 minus 32, I believe. I'm looking at negative 7. All right, so right off the bat, we know that our discriminant is negative, so we're going to have 2 imaginary roots, 2 imaginary answers. And if we build the quadratic formula around that negative 7, opposite of b, positive 5, and then 2 times a is 4. All right, there's our basic version. The only thing really left here is we're going to do 5 plus minus I root 7. Can't simplify that any further. And then we'll just go ahead and split it up. So we'll do the 5 over the 4 plus minus the root 7 over 4, and then just stick an I next to it. So the 2 zeros or roots for this are 5/4 plus square root 7 over 4i and 5/4 minus square root 7 over 4i. If you remember from the previous unit, that means that the graph will not have any x-intercepts, okay? Because only real roots will appear as x-intercepts. We had that in one of our previous units when we were doing this in Unit 1. But here's the graph of that very equation. Notice it does not touch the x-axis at all. You can imagine that it does, but it doesn't in the real world. So we just kind of move on from there. All right, sliding on down. Complex conjugates, you remember how that worked. That was the whole a plus bi, a minus bi. Right here, we have -3, +3. We have this statement here, 2 minus I. Since that is one of them, we know that its conjugate, 2 plus I, is going to be another one of the roots. Okay, the whole idea of doing the conjugates, this applies anytime you're dealing with non-rational roots. Okay, the 3 and the -3, those are just regular numbers. Could only one of them have worked? Sure, why not? But it says here, if a plus bi is a 0, then a minus bi is also a 0. Alrighty? Yeah, if you are using in Schoology, when you have to list them in order, if a number does come up more than once, just go ahead and yeah, list it twice, and you'll be fine there. I know that's a limitation to that particular program. On paper, you won't have to put it in order. That's why a little bit later today I am going to go ahead and upload for you guys some PDF worksheets to work on. It's not going to be, like I said, something I'm going to necessarily collect, but so you can get in the habit of just writing down the answers, and then when you show those to me, I'll be like, oh yeah, that's what you were supposed to get, and you don't have to worry about it. Okay. Completing the square, the other way to go about doing this. Now, the only issue is, as far as you're concerned, the only time to use completing the square is when this happens to be monic and when this is an even number. If this is an odd number, you're going to have fractions if you're okay with that, because we have a calculator. Hey, that's fine too. But this one, I'm just going to rewrite it. X squared plus 6x minus 1 equals 0. I just changed the f of x into a 0. How the graphs work? Yeah, sure. Let's see here. Let me go back up here for you. All right. As far as the parabolas go, okay, you've got 3 possible situations where you've got 2 imaginary roots. You have 1, that is a terrible drawing, but there you go, real root, and then you have 2 real number roots. Okay, now that's what we were doing with parabolas, quadratics, second degree polynomials. Everything is going to stay the same for the ones that we've got here. This happens to be this guy, x to the 4th minus 4x to the 3rd minus 4x squared plus 36x minus 45 graphed. Okay, you'll notice of these 4 numbers, the only ones that are real numbers are -3 and +3. Well, there's -3 where it's hidden right there, and there's +3 where it's hidden right there. And as far as what the graph does when it's imaginary, okay, well, it just, as far as you need to worry about it, it does something. The only, as far as we're going to go in our class, is looking at the actual real zeros where they hit the x-axis. Everything else is going to kind of take care of itself as we're working through those. Alrighty. And then, yeah, if 9i is going to be one of your roots, then -9i will be. If we wrote 9i down, that's the same thing as saying 0 plus 9i, so 0 minus 9i would also be one of the roots in that example. Alrighty? Cool. Is that good for everybody, I think? Okay, cool. So here we go. The oh no, we haven't finished this one yet. We'll add 1 to both sides. course, that is not a 0 anymore. I don't know why I wrote that. There we go. And we make room for the plus box. Alrighty. We skip down to the next step without completing this one. Half of 6 is going to be 3. And then you square that 3 and put it in the box. So you're ending up with 10. Alrighty. At this point, you would go ahead and square root both sides, if you remember that. So we've got x plus 3 equals the positive and negative square roots of 10. Now, the fact that it says positive, negative right here, that's already taking care of the whole conjugate part where they travel in pairs. You'll subtract 3. These are not like terms. So you've got x is negative 3 plus minus square root of 10. The two zeros or roots are negative 3 plus minus square root 10. All right, so that was the two methods that we had before. I'm sorry, I'm looking at your comment here. Okay, so as far as why does it look curvy like that, the curvy, as opposed to like this bit right here, that is where the graph is reacting to the fact that there are imaginary zeros or imaginary roots. All right. When you are making your own graphs down the line, when we get to that part in Unit 3, that is not something that you really need to be concerned with. You need to be concerned with where these arrows are pointing, where these dots are that I placed, and you might eventually be concerned with this point right here, where it touches the y-axis, but that's about it. As far as the, yeah, I think I remember on the homework there was one question that showed up talking about crosses and touches, and that is totally my bad. That wasn't supposed to be there until the next unit. I didn't notice that one, but the short version is if the multiplicity, let me go back to that here. Yeah, multiplicity, if it happens to be an even number like the number 2, it's a touch. All right, you can see that here, how the graph just kind of bounces off or touches the x-axis. And then if it's an odd multiplicity like the -1 and the 2 have, because they only show up once, it's going to flat out just cross the x-axis. So that's what's going on there. Don't stress too much about that. There is only the one question. I'll see if I can remove it so you guys don't have to worry about that one. But, well, you've got how it works now anyway, so you're not actually being asked about how to graph it. You're just looking at, hey, does it touch or does it cross? We'll be worrying about how to deal with that later on, possibly next week, or who knows when, because the whole, you know, we're all quarantining ourselves and all that. All right, putting it back together. So let's go back to this original gem, okay, that we had there. X to the fourth minus 4x to the third minus 4x squared plus 36x minus 45. And we know what all 4 roots are, but we're going to go ahead and practice finding them anyway. So they're right here, they're telling us to use 3 and -3. Doesn't matter which one you use first, they're both going to work. I'm going to use -3 first because it's listed second and I feel like being different today. 1, -4, -4, 36, and -45. All right. Bring that down. Multiply. Add. Multiply. Hold on one quick second. Looks like someone is still having trouble with their laptop. Are any of you guys on the laptop at the moment? Just curious, because what I checked out before is to restart the machine, disconnect from Wi-Fi temporarily, and then at that point, if there's still an issue, you should just be able to refresh the page, and that would kind of take care of all of the issues. That's what worked with the student computer that I have at home anyway. And it should be pretty much following the same rules as the ones that you have. So, oh, you're on your phone? Okay. Well, if we end up having to do it just on the phone, I don't know what to say. I know I was able to access it, like I said, with the student machine that I have at home. But if it's not working otherwise, then I guess that's what we got to do. There we go. I guess you use the phone. All right. Alrighty. I'll check again. It was, like I said, the one I've got at home was working, so I don't know. Of course, I'm also kind of talking to someone that can't hear what I'm saying, so hey, whatever. 21 minus 21 minus 4. I want to say that is going to be 19, I think. All right, and we're going to have now 3 times 19. That's going to be 57. So we got negative 57 here. And we'll go ahead and add that to the 36. And I am looking at 21, which is, I made a mistake somewhere, didn't I? 1, negative 4, 36, negative 45. I did negative 3, which we said was supposed to work. You know what? Hold that thought. I'm using my phone calculator at the moment, which is just a terrible, terrible thing to do. I told you guys not to do that. Let me grab my my TI-36 Pro. TI-36 Pro. All right, let's see here. So I am going to, let's see, 1, negative 4, negative 4, positive 36, negative 45. Is the 19 supposed to be a 17? 21 minus 4. It is. Yep. You're right. It wasn't a calculator. It was totally a phone. And looks what happens when I try to use a phone as a calculator. I get completely messed up. 17. Oh, that's so much better. Okay, so now we're doing 3 times 17. And that, I believe, is going to be 51, which is negative. All right. And 36 minus 51. Ah, that looks so much better. Negative 15. And negative 3 times negative 15 is a positive 45, and you end up with 0. Okay. Phew. All right, that worked out, and I'm going to go ahead and use that as our depressed polynomial. And we're going to use 3 this time. All right, bring down the 1 as usual. Multiply, add, multiply, add, multiply, add. All right, so now you've got this statement here, 1, negative 4, 5. Regardless of if you started with the positive 3 or the negative 3, Either way, once you've done both of them, you do end up with 1, -4, and 5, which is this quadratic right here. This is your constant. That's your x term, and that is your x squared term. I seriously doubt that they would want to sponsor me, but I will say I do enjoy the TI-36 Pro. I highly recommend it. If you're going to go get a calculator, that's what I'm thinking you should probably do. Anyway, guys, now use either quadratic formula, that should be an or completing the square to solve this depressed polynomial, and hopefully we'll get the expected results. If we're going to do quadratic formula, again, A is 1, B -4, and C is 5. So B squared minus 4AC, and you end up with -4. Now, check and remind messages. Alrighty, and we'll build quadratic formula around it. So we're looking at that guy right there. This is going to become 4 plus or minus 2i, and it's all over 2. And since all three of these guys are divisible by 2, 4 over 2 is 2, plus minus. 2 over 2 is 1, or 2 plus minus I. And that was the answer that we expected from earlier. If we scroll back up to right here, here's 2 plus I and 2 minus I. And of course we can still do it the same way with completing the square. Minus 4x space -5. Okay, half of 4 is 2. 2 squared is 4. -5 plus 4 is -1. Square root both sides. And we've got x minus 2 equals positive and negative I. So when you add 2 to both sides, we do get x equals 2 plus minus I. Same result. Pretty much if you're looking at a monic, if you're looking at an even number here, if you're a bigger fan of using completing the square, go for it. If you're not as much a fan of the quadratic formula and it's not in those two cases, I can talk to you about how to do those offline, or maybe heck, since I'm already doing this, might as well go ahead and start making some videos of that too. But yeah, that is how we go ahead and get those results. Alrighty, so on our own. Now this one has a couple of things in here that I want to definitely make sure that we're aware of. We're not going to go ahead and use this yet because we don't know it yet. But our possible choices, there aren't very many of them. We can use either positive or -1 or positive or -7. Those are all the choices. Okay? But think back to when we're dividing polynomials. This has a degree of 4. This has a degree of 2. This has a degree of 0. Did we miss anything? Hold on. Got a question from Remind. Do an example of how to do the equations on Schoology that ask you how many zeros. Well, that's just going to be the degree. Whatever the degree is is the number of zeros. That's the essence behind the fundamental theorem of algebra. This one right here, when it's done, since that is a 4, it's going to have 4 roots total. This one here, fourth power, had 4 roots total. That's a 2. It had 2 roots. That's a 4 again. Do I have anything else other than 4s and 2s? I apparently am really enjoying 4s and 2s on this. Oh, here we go. And that's a 3, which means there's going to be 3 roots for that one. So whatever the degree of the polynomial is, that tells you how many roots there's going to be. Now, if you were looking at something like, I don't know, this, and this is just as an aside, this is in a factored of sorts form. If you were to multiply it out, you would end up taking the x and the x, multiplying together, and you get x squared. So you're going to have a degree of 2, meaning you'll have 2 roots. If you have something like okay, this guy right here, if you multiplied it out, that you don't absolutely have to do, but if you did, when you multiply the x by the x squared, you'd get x to the 3rd power, which means this one would have, it's going to have a degree of 3, so it'll have 3 roots with it. Okay, so that's, I think, about as complex as it should be getting in the homework. If it does get more than that, let me know and we can fix that. But anyway, back to this one. It starts off with x to the 4th, but we're missing a 3rd degree, so we do have to have a 0 x to the 3rd, if you remember placeholders, plus 6x squared, plus another placeholder, 0x minus 7. Okay, so this is the whole thing written out. The ones that I gave you that involve any placeholders, I think, unless I missed one, because there's a good number of questions in the bank, I think that I put the zeros in there for you. If I missed one, let me know and I can fix it later. All right, we got 4 choices: positive 1, negative 1, positive 7, negative 7. Really doesn't matter what we start with. I always recommend starting with 1 and negative 1. All right. Bring down the 1, that's 1. Add, you get 1. Multiply, you still get 1. Add, we have a 7. Multiply is 7. Add is still a 7. Multiply is a 7. And there we go, finally, a 0. So that worked, yay. All right, so positive 1 is going to be one of our roots. Let's use this again and try negative 1. Just because. All right, negative 1 times 1, that's negative 1. That is a 0. You would add the exponents. Jada, you were asking. Yeah, if you're multiplying the bases, you add the exponents. Okay, that's 7. And that gives us negative 7 and 0. Alrighty. When we get down to just 3 numbers, it's probably a good time to go ahead and just see what that really is. This is your constant, that's 7, 0x, and x squared. Okay? In other words, you've got x squared plus 7. Okay? This one right here, if you found the discriminant, you're going to find a negative number. So it's definitely not going to be something we can find by using synthetic division. It's also going to be, on top of being imaginary, it's also going to be an irrational type imaginary, meaning instead of being something happy like 2i, it'll be like the square root of yada yada I. All right. So best way to go ahead and do this one would be to go ahead and solve it. Where did I get the 7 to test? That came, saw what I crossed out here, the rational root theorem to determine. That's what I just kind of use. It's going to be something we can use in your head. I don't want to really introduce that. It's not. I want to focus on this for the moment, which is why all the homework with fundamental theorem gives you what numbers are worth trying. When we get to the next piece where you have to come up with them, we'll do that. Let's see, what's today? Wednesday. I'll probably end up either doing that tomorrow or Friday. And that should be a good way to kind of close. Yeah, you know what? I'll probably just do it tomorrow since I have an assignment up there anyway. So yeah, tomorrow when I stream, I'll do the rational root theorem, which kind of goes really, really hand in hand with this right here. Anyway, find the 2 remaining roots. Guys, I'm going to do this 3 ways. You are going to get sick of this problem. All right, if we use quadratic formula, that's going to be A is 1, B is 0, and C is 7. So B squared minus 4AC is going to give us negative 28. And then build, opposite of B is still 0, over 2 times A. You're looking at the square root of negative 28 over 2. Square root of 28, that's 2 times 2 times 7. So we have a pair of 2's. It is negative, and there's still a 7 inside, and the 2's cancel. So what you end up with is positive and negative I square root 7. Okay, if you want to do it that way, that's cool. Me personally, what I would probably end up doing, simply because this has no linear term, and if you remember those questions from Unit 1B, if there's no linear term, you can just go ahead and use the square root method, which I'm doing right here. Just kind of takes away some of the steps. You end up with positive negative I root 7. Okay, so the 4 roots, there's 4 of them. The 4 roots are negative 1 and positive 1, the 2 that we found by synthetic division, and both positive and negative I times the square root of 7. Okay, so that, yep, that is everything that is on those. How long have we been live here? All right. Yeah, it's been about 40 minutes or so, so I don't want to keep you guys on here too long. So I'm going to go offline. Again, you can reach out to me by Remind to ask me any questions. If it's a question specifically about this video here, if you want to give it a go, I think I have it set up now where I would actually get any YouTube comments after the fact sent to me live, so I might be able to answer it that way. I don't know. Like I said, I've done videos before, but not the live thing. This would be my second go at it. All right. If there's nothing else, then I will see you guys tomorrow. Probably going to do a different time just to accommodate some of the people that haven't been able to reach in so far. But we'll do the rational root theorem. Thanks.